Hello and welcome to this new post on sustainability finance actions number 4. So as before, we start with the sustainability accounting circle that starts with the measurement reporting of sustainability issues. But then of course the focus is on the action. And that's what we will focus here about something that we can do to deal with dark or so-called redundant, obsolete and trivial data, ROT data. Why is this an important area? Well, the storage of this data consumes electricity, and at least if you store it or somewhere in the internet on a cloud drive, not on a local hard drive that you put in your cupboard or somewhere. But as soon as you store this data, let's say somewhere in a cloud, you consume electricity and you cause CO2 emissions. And of course, what we should try to do is we should try to clean up data that we do not need. And for the data that we need, we should try to minimize our CO2 footprint. And here's some background information about that. So why is that important, or is that important at all? So let's have a look. And what I share you here are a couple of research papers I was going through. So I always put the sources here. And on top I share you a graphic from one of these papers. And this just separates structured and unstructured data. And in each branch you have kind of ROT or dark data. So in the following I will just call it dark data. Whether you follow this classification here, or whether you say, okay, here's some backup data, that's actually something I regularly need. I need to analyze it. So that's not my dark data. That is not the point here. The focus or the point that I want to make is that we have different kind of data, and many of them can be classified as dark data. And some of the studies that I showed you here, and if you do online searches, you will certainly find more. They say, okay, around 50% to 99% of the data that you have are dark data. So they are actually somewhere collected, stored and never used again. And then the question is, okay, what's the footprint of these data? Why should we minimize that? And here again some papers where I get this data from. So these research papers, they were analyzing, hey, how much electricity do you need to store the data and to transmit it? And the calculations they made were for the year 2015. Well, it's pretty old data, but they also say, okay, hey, we have technological changes, and because of that, the energy consumption that we need for storing and transmitting data, this can be halved every 2 years. There are some other papers that say, okay, the numbers that you show here, they fluctuate wildly. And the second paper compares, I think, 14 different researches that were made in this area, and where you see a wide variety of electricity consumption for data storage and transmission. And then there's another thing that says, okay, if you store data and transmit data, then of course this technological change helps us to reduce the electricity consumption, and of course then the CO2 footprint. But there is a rebound effect. So if you can reduce your CO2 emissions, people basically start to save and store more data. And that's also something that needs to be taken into consideration. So if we want to make some calculations and have a look at some data, then I need an assumption or a starting point. And the starting point that I have is this blue highlighted line. That's from the research papers that I showed you. And they mention for the storage and the transmission of the data, you need approximately 106 kilowatt hours for 1 terabyte of data. And then I just followed the principles. So I said, okay, I divide this number just by 2 every year. And then in 2021, I end up here with 13.25 kilowatt hours for 1 terabyte of data that is one time transferred and then stored for a year. So these are annual data. So I move the data basically once a year, but don't delete it. And then the question is, what's the CO2 footprint? And again, here there are different sources. So if you use this one, the EPA, which is kind of standard setter in my opinion, you end up with 10.3 kilo. But there are other providers such as this electricity map that focuses on different countries and regions. And they say, okay, if you're in Germany, you need a bit more compared to data storage that might occur in Sweden. Why? Because in Sweden, they use more green energy. Yeah? And for Australia, this thing might be different. So have a look at this source. It gives you quite interesting insights. Okay, and then if we have this wide variety of CO2 emissions that can be caused by electricity consumption, I said, okay, let's just take an average. I say, okay, around 5 kilo, that is what I'm going to use for the following consumption calculations. That's 342 gram per kilowatt hour. And that's only for the data storage. Now, let's move to an example. So if I'm a small or medium-sized company, at least for German terms, then I have, let's say, 100 employees. All of these employees have a mailbox, and the standard mailbox size that you probably have is around 50 gigabyte. And let's say you use 50% of this mailbox size on average. So if you just calculate these numbers and calculate the CO2 equivalents, then you end up with 12.5 kilo that the email accounts of these 100 employees consume in terms of CO2. That's not much. It's really a small number. So should we care? Well, then I tried to calculate this for Germany. So in Germany, around 70 million people have mail accounts. And if you just use the same numbers, then you end up here with 8,750 tons of CO2 equivalents. And if you use this kind of converter, then you can calculate the kilometers that you can drive with a car to come up with the same CO2 emissions. And that's around 42 million kilometers with I would say, not the latest or not the newest car, but also not the oldest one. And if you look at this number, then this is approximately a one-time drive around the globe. That is what is caused by storing the data of the email accounts of all Germans for a year. And of course, if you can reduce that, then this is a bigger number. But let's have a look at another example. In the previous post, I often showed you my demo machine, a virtual machine that runs Dynamics 365. And the disk size that I have is around 1,700 gigabytes. There are different disks. If you add them all together, that is what you get. And if you just assume, okay, we do not use all of that, but just 30% of that, you end up with approximately 500 gigabyte or 0.5 terabyte of data. And for this machine, if you just have this data and make the same calculation, I have a CO2 emission of 2.5 kilo for the data storage per year. That's also not a lot. So that's very small, I would say. But now that's only the data storage. Now, if we have a look at the energy that is consumed while running the machine, then things are different. And here I found a paper, basically an article on these dev blocks from Microsoft, where they make a comparison of different VMs that run for 24 hours. And based on their settings, they consume between 3.5 to almost 5 kilowatt hours for 24 hours. So if I take this number and convert it into the working time, of Germans. So I assume, okay, I'm working in Germany. I run the machine every day, 8 hours per day while I'm working. Yeah? With this number of hours that a typical German works, we have these numbers of days. This allows me to calculate the total kilowatt that I need to run the machine. And then I can convert this in CO2 emissions. And then we end up here with 94 kilo. If we add the previous 2.5 kilo for the data storage and do a bit of rounding, then we end up with approximately 100 kilo of CO2 emissions for this VM to run it and store the respective data for a single year. Yeah? So one machine processing the machine 1 year, doing some operations and tests, causes 100 kilograms of CO2 emissions. Yeah? Okay, that's also not that much, yeah. But remember, how many VMs do you have in your company probably, and how many do you use while you are running projects? Yeah? There are a lot, yeah? And reducing this kind of CO2 footprint, this might be worthwhile. Yeah? Well, you might say, hey, Ludwig, don't forget. Yeah, if you take a look at the study, then they come up with a different CO2 emission. Why? Because the study calculates with 30 grams of CO2 emissions per kilowatt hour. That's a very low number compared to the more than 300 grams that I used. And why is that? Well, because they assume the energy mix of Norway, if I'm not wrong, that has a very green electricity production. Yeah? And again, don't forget, we have Microsoft and other cloud providers that pledge to run their operations by 100% renewable energy, which is excellent. Yeah? But still, the energy that you consume for your VM that you might not need 8 hours a day, this is energy that could be used elsewhere. So we have kind of opportunity cost. Yeah? So the energy that is produced for running your VM could be used for, I put here hospital, school, you just put whatever you want. Huh? And that is why I say, okay, even though you might use 100% renewable energy for your VMs and all of your data and storage and whatever you do, deliberately think whether you need to deploy things, whether you need to set up new mailboxes and all of these things, and how you run your VMs. Yeah? Because the energy that is produced might be used somewhere else. Yeah? Now the question is, okay, what can I do? Yeah? And here I have a couple of tips. So the first tip is, okay, clean up your cloud mailboxes, your other online data that you have. And there are a lot of tools. Yeah? I have here a video for you that shows you how you can use these data governance tools and automatically clean up old emails, such as the one on the right hand side that you do not need. Yeah? Then another thing that you can think about, yeah? I don't say that this might be a solution for all, but you might think about it, is to store some of your historical data offline, yeah? On a local hard drive. Yeah? For example, some kind of legal contracts that you probably will not need on a regular basis online. Yeah? Of course, if you do that, you have to think about many things. Yeah? How often do you need the data? Yeah? What kind of security or data loss preventions do you have in place? Yeah? Also, don't forget that the hard drive also has CO2 emissions because it needs to be produced. Yeah? And some of them even require energy to run. Yeah? But it might be something you can have a look at. The other thing when it comes to virtual machines, and that's what I have from this post here, is where they mentioned something about right sizing. Yeah? Right size your application. Yeah? And there are some great tools available that you can use. So if you run VMs, have a look at this post here that says how you can dynamically adjust VM sizes, service plans, depending on the time of the day and the expected usage. Because the energy production and the CO2 footprint might be different based on the time of the day you run something. Yeah? Then another thing, and that's a post from one of my friends from Dynamics here. He once posted an article that says, okay, how can I automatically start and stop my Azure machines? Because I mean, if you're not at work, or maybe if you're at work, you might not need it for 8 hours. So shut it down automatically. But when you do that, consider, okay, when do you have workloads? How long is the reboot time? And other things. And here's the link to this article. So just check it out. And then, of course, there are specialized tools that help you to identify and minimize black and ROT data. So have a look at these sites here. And of course, also on the app source, we have here the sustainability calculator, which is in preview, so it will probably have a different name in the future. That's always something that happens, that things will be renamed. But the idea and the tool will still remain here. So please check it out to see what footprint your machines and your environment has, and what you can do possibly to reduce it. Okay, so that's all what I wanted to share basically. Here a quick summary. So what did we investigate? The dark and ROT data. And of course we extended it a bit and had a look at data processing for VMs. Here are some of the actions that you can take. And the good news is that all of these actions can be implemented in the short term. Of course, you have to think about legal regulations, how to archive data, what about data security, data protection laws, and so on. But there are a lot of tools that I shared with you that can help you to realize that. And the sustainability effect, okay. If you look at an individual, the environmental footprint of a mailbox, even if you delete all of your old emails, that's very small. But if you look at your company, if you look at your region, at your country, if you look at more than yourself, and if everybody follows this kind of principles, then there is a large impact, and a large reduction that we can realize. Okay, so that's it what I wanted to share with you today. As usual, if you have comments, just put it in the comment section or send me an email here. That's it for today. So thanks a lot for watching and listening, and looking forward to seeing you in the next post then.